Hello and welcome back. Today I have a Kaiweets clamp meter and it was sent to me by the friendly people of Kaiweets. It's the HT208D. They asked me to do a review. It is an AC-DC clamp and it can go up to 600 amps, but it can also do resistance, capacitors, diode mode. So we're gonna play with it. I will put it properly to the test. So I have my DMM check plus for the resistance, the capacitors, and I have here for AC current I have 10 times in one time. I just put it in between my plug, and if we really want to push it to 600 amps, I cannot do that with my power supply, but I made some amplification coils. This is a 20 times turn, so if I use like 30 amps, which is already a lot, it should measure like 600, and I have a smaller one for the smaller currents. And I like to talk a little bit about the detection method of the current between an AC only clamp and an AC-DC combined clamp. And it's going to be fun today because it is near 27 degrees. It's 26.8, but when I start using later all the power supplies and start to burn all these amps, it's gonna be a little bit hot today. So what we have, the Kaiweets box open. Oh wow, I like that. Nicely. You can put it also on your belt. Manual. Let's see. Oh, it's quite big. Oh, look at that. Big, big. I like that, especially when I need to test later with my big coil. It needs to fit. It comes with batteries. I like that. I like that from Kaiweets. I think they did that already from the smart multimeters. They always provide you, if they are good or not, it doesn't matter. You can immediately use the meter. Oh, it also has temperature measurement. Okay. And the probes. The probes look really nice, and I like this silicone wire. Has a good feel. It is cut 3 for 1000 volts, cut 4 for 600, and of course this will reduce the rating, but it is still a cut 2 for 1000 volts. So always use your protectors if you can. The batteries, we use all 3 of the AAA's. So let's have a look around. It has a dark display. Oh well, look at that, bright. How about, you can really look at all the sides without any problem. For the voltage and the resistance and the capacitors, we have here connections in the bottom. That's why you get those 90 degrees also, so it takes less space on the bottom if you use the cables. It has non-contact voltage detection. It has a hold button and a flashlight, and you can stick your probes also here. Let's have a closer look at what it can do. This is the AC and DC current, and for Inrush, of course, I think it's AC only. It has a VFD, I think it's voltage frequency drive, this kind of filtering that you get a better readout. We have a 60 amp in a 600 amp setting. We have here for the voltage also with the filter. We have frequency and percentage, which is the duty cycle. And we have here the ohms, continuity, diode, and capacitors. We have the temperature measurement, also goes into the bottom. And here we have also voltage, AC-DC, just like here. Here we have AC filtering for the voltage frequency drive, but here we have low impedance. That's also if you have distortion on your line, or you're just measuring a phantom voltage, then because of a lower impedance you will see less of a phantom voltage. And here we have the non-contact voltage detection and live detection. The live detection, you only use one probe. You stick it to the cable to see which one is live or not. So before I do all the testing, I like to show you a little bit the difference between an AC only clamp and an AC DC combined clamp. Here I have two older clamps. This is a little bit more modern than this one. This is really like 50s or 60s. Both are AC only, and they work on the principle of induction, like just like a transformer. So that works great for AC. But this single winding that you sort of have needs to be a closed loop. So what you often find is that they have a metal part here, and they need to close this loop. And it is of course a clamp because you want to be able to connect your wire without cutting the circuit. This with the modern thing, it's exactly the same. This is a fluke, does even RMS I think, but the principle is still the same. You find here a metal on one side. Here they even have a little thing sticking out, so just to be sure it closes even better. And here we have the same but the other way around. So it is the same principle for both because they are AC. We need to be sure that this loop is closed. Then we have a look at the DC one. And of course also you need this single winding, but they do one thing a little bit different, and that's because of the DC component. Here we have one side, we have again the metal, but on this side there is not. It is just a plastic notch, and that is the Hall sensor. And it's kind of a magnetic field sensor that transfers the magnetic field into electricity, and it is very commonly used also in automotive. And it's quite fast, so they can even measure rotation of axles or crankshafts, and it's very, very nice invention. So that's probably also the reason they needed to add this Hall sensor. You need to calibrate it. It will bring a little bit extra cost. That's why it's usually cheaper to have an AC only. So I have the DNM Check Plus. It's nice because we can measure voltage, we can measure current, and we have here capacitors, coils we can't measure, and resistance. Let's try to measure. Well, for the current we do later. I don't think it's realistic. It goes to 600 amps, and there is even a 60 amp setting, but this one delivers exactly 1 milliamp, but I don't think it's realistic because a clamp is not made for those low currents. So I will try that later on my Advantage, and I think if we can see about 100 milliamps, that would be realistic. So, but for the voltage, let's just see. So we start here with the voltage, and we should be able to see exactly 5 volts here. So 5 volts, yeah, almost there. It seems to be 5,000 or 6,000 counts because we still have some space here, so I would say 6,000 counts. It says 27 degrees. That must be the internal sensor because I didn't connect the sensor, and it is indeed 27.2 already in the room here. It says less precise. This is the LVO2A, but it is actually pretty good, but it is a lot more flexible, and we don't have too many digits below the zero, so this will be perfect here. Let's see, even 100 millivolts it can measure. 1 volt, 2 volts, 3 volts, 5 volts. Now it's interesting to see how many counts it has. If we go a little bit up, a little bit up. Take some time to stabilize. And the bar seems to have the same speed as the digits, so it's not that the bar is faster that you sometimes see. And will it do this? And if we do one more, it probably switches over. Oh, it even can do a little bit of overrange. Look at this. Yeah, and here it switches over. So it's even 6,200 counts. And what about AC? Well, I'm a little bit less flexible in the AC, but let's switch it over. AC voltage. This should be around 5 volts exactly. RMS we see here 100 Hz already in the secondary display. And I can also go to 10K, I think. but then it will usually, because of the filtering, it usually will not show that. And if we go back to 100, it is good. So it is true RMS, because we have very close to 5 volts, otherwise we would have 5.5. That's good. What about the frequency here? So that is again 50% with the 100 Hz. And what if we go to 10K? Here we have it, 10K, exactly 50%. So that seems okay. Let's go to the resistors. $100 ohms. Oh, that took a while, but exactly 100, what you expect. The 1K is super spot on. It's a fractional high. No, it's good. Okay. We go 10K, 100K. Well, that is no problem. What else we have? We have continuity. Then I like to know in what resistance it will beep and is it any fast, and it seems pretty fast. So 20 ohms, it should beep. Yes. Okay, here we have it, and we have even a red light indicator. So the continuity is around 30. Okay, next option is diode. Does it do diodes? Yes, you see the voltage also. That is nice. And the other way around, it does nothing. What is the voltage it uses? 3.26 volts. We go to capacitors. I start here with 1 nano, 10, 100, and 1 micro. And that's actually quite fast. I found the resistance a little bit slow. Go back to resistance. It really needs to scan that. But the capacitors were actually fast. Usually you see the other way around. But the values are good. No problems there. Then we have the temperature sensor. The external sensor. We have that in Fahrenheit and in Celsius. That seems to be okay. 27, it's what it is. That is good. And I think here we can switch up and down. No, we cannot. It is just as it is. So your Fahrenheit is in the top and the Celsius is in the bottom. And in the other settings you have your temperature just there. So that was all the low voltage stuff. Let's do some amps, and first I like to see at what value you get a proper readout. So I think we start somewhere in the 10 milliamps, but I would guess that it starts about 100 milliamps because it goes to 600 amp or 1000 even. So it is really made for these higher values. So let's do one winding. First we need to zero in the correct position that we're using it. Okay, 10 milliamps. Yeah, it's 1 or 2. It is too close. 20, 30, 40. Now it's already good. 50. Around 50 it seems to start to work. Now we have 0, 5, 6. But it takes a little bit. 7. 8. But clearly this is too low for this meter. But as I said, we can also not necessarily expect this because it's made for 60, 600 and 1000. So. But what you can do in cases like this, you can use this 10 turn coil, what I'm going to do, and then your readout will be 10 times higher, so you actually get a better view on it. So I'll put the 10 turn here, I will put it to 0. And I activate. Now we have 10 and it should read out as 100. And we are still in the lower limits, but if we go to 20, should read 200, etc. Let's go to 600. You can see that the readout is already a little bit better. Let's see, with a little bit more current. I set it to 5 amps maximum. Let's do the readout switch on the outputs. I will zero this one, and I put my electronic load on 1 amp, and we have 1 amp and we have 1 ampere. So starting from 1 amp it is spot on. Let's go to 2 amps, 3 amps, 4 and 5. I actually want to do a little bit more. Now we have some more power. This one goes up to 60 amps. We have readout here. This amp meter is not that good. We have the readout here of the meter, and here is the electronic load. It's now set to 1 amp, and in the corner here we can see the meter. It is near 0, so let's see. So this is 1 amp. We see 1 amp. We go to 2, 3 amps, 4, 5, 6, 7, 8, 9, 10 amps. It is fractional low. We have the same here. It says 10. Let's go a lot higher because we have this 60 amp setting. (26 amps). That's my electronic load, a little bit noisy. 40 amps. It is stuck at 40 amps. Oh yeah, my load doesn't go higher. Let's try to use the coil. Okay, we set it the coil. I'm not sure if it goes minus or plus, because then we just need to set it to the other one. It is 20 times, so that means if I put 1 amp, it should display as 20. So I should have around 20. Yeah, it's minus, so I will move it to the other side. Well, it's pulling a bit because the cables are very rigid, but I think we can see both. I switch it now on, and we see indeed almost 20 amps. And now we can go a lot higher. So let's go to 200 then. It doesn't switch over to 60 amps automatically. That's a little bit weird. When you are in 0 mode, it doesn't auto scale in DC. Because here we have 60, then I go a little bit higher, and it says overload, overrange. But when I switch off the 0 and I keep it into auto, we have 60, and I go up, and there it goes. Apparently in these high currents it doesn't matter anyway if it's 0 or not, because we're talking about crazy currents. So if I go now to 10, I would have like 200. Yeah. Go to 20 amps, and then it will say 400. Yeah, it's still going. Now we are close to its maximum in this range. One higher. Yeah, it starts to beep. I go back. Let's go to 1 higher. Back to 600, and we go at, I can go to 400, so that means 800 here. Yeah, and it is always this 14, 15 in the end here, that it is a little bit off. So let's try some AC. I have here my power supply. I connected also the electronic load. This is the primary side current, so that is here the same exactly. We are here on the 1 time, and we can see we can't read it out, but if I change it to the 10 times, we have about 72, 76, so that is correct. So let's put some load that we have 500 milliamps here. So I switch on the electronic load, a little bit higher. So we have a little bit more than 500 milliamps here. It says here 0.56, here it says exactly 5. So let's do that to the 10 times. And here it indeed says also it is a little bit more, 581, 581. So because it's 10 times. So in the higher values it reads a little bit better than in the lower values here. Let's go a little bit higher. Let's put it 1 amp on the primary. Yeah, there is some noise here. For my electronic load we are about 1 amp. And we see again in the lower values it is just about doing it. But when we do the 10 times it is already a lot better. Then we have also the inrush current. Inrush current is the current, for instance, when you start an electromotor. The startup gets a very high peak, and it could be higher than your fuses, but because it's so short, your fuses usually don't blow. So I have everywhere in the house 16 amps fuses, but the startup of the vacuum cleaner is a lot more. So that means in this special measurement, usually it's over like 100 milliseconds, it will measure there where the peak is. So we switch it to AC current, function, and now it is in inrush. Put it to the 1. And the startup current is 27.4. Let's do that again, just to be sure. Now it's 27 and a bit. Well, I did the same with my oven and it also says 27.3. So I think the inrush is good. And then we have the non-contact voltage detection. You switch it over, you get the green light that it is detecting at the moment, and then you hold the cable close by, and then the cable is powered. So that was it, the current clamp from Kaiweets. It's the HT208D. Very complete. I like it. Comes with proper probes included with batteries. It even has an external temperature sensor, although the internal sensor also works good. It was nice also with the delicate things like resistance, the diode mode capacitors. It was kind of spot on. The continuity was very fast. I liked it. When you tick, it was immediately there. Clearly it is made for the high currents, the clamp. It is up to 1000 amps, and you can see that when you start to measure really the small values, that it is not his strongest points there. But when we start to get in the higher values, it really did the job well. And also the inrush current measurements were very realistic compared to my other meter. Very nicely done from Kaiweets. Thank you for watching, and I hope to see you next time.